I'm Brian Johnson, and this is Greg Cummings. There's several other Intel people around there we go, around the hall here. So we're going to talk about 10 gig Ethernet best practices and some of the new features that are in vSphere 5. Obviously, with a group this size, my normal having interaction with the audience is quite limited as far as what I can do. Please come down to the Intel booth. We'll have we have the demo with the best practices that we'll talk about here up. We can walk through them some more. You can ask them in-depth questions. We have whiteboards and everything up there that we can work with specific questions or concerns or challenges or whatever you want to talk about. Come down and we can discuss that down there. The format of this, I'm going to break it up into 3 different areas. One is around system requirements for 10 gig. The second being taking advantage of some of the network I/O control and the QoS features that are built in to 5.0, some of the new ones. I'm not going to cover every one of the new features in 5.0. There are other sessions for that. Really talk about what is going to impact you as far as the 10 gig, a 10 gig deployment, how to get how to take full advantage of the network, and then also get into the unified storage. So some of the new features around the FCoE and iSCSI and how to take advantage, how to use those, and some of the gotchas that you will start seeing as network traffic increases. And now that we can take advantage of 10 gigs of bandwidth across multiple 10 gig ports, and we're consolidating storage and network traffic, what that means. And that's really where a majority of the presentation is going to be focused on in each of these 3 areas. So over the last couple of years, I've been working on a series of white papers. The first one I came out with is in February last year around 4.0, really about the transition from 1 gig to 10 gig. So taking those 8 to 12 1 gig connections and putting it over to 10 gig. When I started that a year prior to that, there were a lot of questions on, what about quality of service? What about, all this traffic, security, and how is all that going to work? And there was still a major mindset or paradigm around 3.5 implementations where you had to have a single VM to a NIC. I mean, there was a lot of one-to-one relationships being built up. And that's what that paper focused on. The third paper was the quality of service, so really taking in the 4.1 functionality with network I/O control, some of the teaming. And I'll cover some of the concepts that I covered in that and how they relate to the 5.0 in the first part here, and then there's a majority of the stuff into the 5.0 stuff. And then I work with a lot of the OEMs. We'll take that content, I'll work with them and make sure that their systems, so we'll add their system specific content into there on how to take advantage of it. And even VMware took the papers and rebranded them as VMware papers. And then there's some different articles and stuff. So you may have seen some of those articles out, and I was the lead in developing those, and the people around the room here contributed to it. So the transition from 1 gig to 10 gig is really more than just going faster. There's a lot more to take into consideration, especially at the system level. We get a lot of calls from people saying, "Hey, I got this one your X520 adapter, and it's not getting line rate. I got this I hate our names for our controllers, but the 82598, which was the predecessor to those, which was the codename Oplin. You'll actually happen to see that up here. How come I can't get line rate on both ports? And now that that VMware is optimizing for 10 gig deployments, we can hit line rate across multiple ports. So a lot of these things that I'll talk about, you'll start seeing them if they weren't configured correctly, and where some of it may seem a little remedial sometimes, it's something to really look at because it will have performance impacts on it. So what we'll do is we'll look at some of the deployment options, determine the number of ports. I'm not going to get into telling you how your networks or how to, how many ports or whatever you need. That's something that has to be worked out. I'm going to talk about how to balance it out and make sure that when you do put that number of ports in, that you do get the full bandwidth. And then also look at how to manage your network bandwidth requirements. So around 10 gig, we do have the different scenarios as far as cable connections, which have impact on the type of information or type of traffic you can handle, the type of architectures that you have in your data centers, and then also some of the technologies that are available. So I'm just going to focus on the rack and tower side. The blade side has a different architecture that I didn't want to get into in this presentation. But around 10 gig, SFP Plus has been a kind of a de facto standard because 10G base T hasn't really had the power or the switch density needed in order to be widely deployed. That's changing. A lot of the 10G base T switches are now becoming available with higher port counts. And then also you have fabric extenders that will extend your SFP Plus, like a Nexus 5000 has a Nexus 2000 for 10G base T that will allow you to have both types of connections. And the reason I bring up 10G base T is that is what you're going to see on as a LAN, a LAN on motherboard, on the servers coming out in the next generation. So you will start seeing 1 gig ports and with some 10 gig, and then you may see, and you will see, some boards that only have 10 gig, 10G base T. Now the benefit of that is that it is backwards compatible, so you can plug it into a 1 gig connection, 1 gig switch, and you can use your existing infrastructure. But there are some things that you need to be aware of when that starts to happen. Your manageability, connecting, how you do power management and whatnot, that does get impacted. So as you're making your decision on what kind of infrastructure, keep in mind most SFP plus adapters don't support any kind of wake on LAN or power management functionality. So if that means that you have to implement a 1 gig connection or use a ILO or DRAC connection for your power management in order to power the server back up. You can always shut them down, but powering them back up can be a challenge when you're on 10 gig. So depending on how you want to configure, you can use your top of rack using direct attach, or if you want to do end of row, you can use either base T or SFP Plus. This is something to take a look at. Make sure that you understand the drawbacks and the benefits of each side. The one thing around 10G base T is that the adapters that Intel provides that I'll talk about with FCoE support FCoE. They're FCoE ready on 10G base T. We don't have any switches in the ecosystem right now to support that. So we are working with the switch vendors. We're working with the industry to create a standard and bring that out. So you should see it happen. I don't want to make any promises, but I mean, the adapters are available. They will support it. It's just a matter of working the ecosystem. So if FCoE is critical, then you need to make sure you stay on the direct attach or the fiber side until that gets rectified. Now, here are some of the new storage and networking maximums for 5.0. It's great because now we support up to 8 10 gig ports in 5. That's a lot of bandwidth that we have available now. The other thing is that we can do a combination of 10 gig and 1 gig, so 6 10 gig ports and 4 1 gig. So that's another combination we can do. And then you can also do 32 or 24 1 gig ports if that was something you wanted to do. The point that, I mean, obviously you have access to that information, and the piece that I want to make, the point on is a 2-port 10 gig adapter, Ethernet adapter, requires a PCI Express Gen 2 or a 5.0 gig speed with 8 lanes, so by 8, in order to hit line rate on both ports bidirectional. As I said, a lot of people haven't seen this type of configuration, or performance issue, because it's really hard to hit that kind of line rate, but it is there. And as you start taking advantage of 10 gig vMotion, or vMotion over 10 gigs, you will see these bandwidth limitations, especially if you start adding storage. So when you make your server choice, you have to look at the PCI bandwidth available in each one of these in the slots, because not all servers have by 8s, or they're not all by 8 connections. So especially like if you're moving into these 1U servers, you may only have 1 or 2 slots, and they may not all be by 8s. They may be a by 16 with a by 4 on the other side. Got to make sure that your by 16 doesn't downshift to a by 1 if it's not a video. That was something that happened early on. People would stick a network card into a by 16 and it dropped down to by 1 speed. That was surprising. So make sure that the systems that you're plugging these 10 gig cards into actually can maintain that by 8, and that has enough bandwidth. So if you look at the Dell system there on the right, the R9710, or on the left, is whatever side it is on you guys, right? There are a bunch of different options. You can get that that optional 6 by 4s and 4 by 8s. You got to be careful, because that may be a little surprising if you try to plug a bunch of dual port 10 gig cards in there. And the reason I say it could be surprising is not all by 8 connectors are wired with all 8 lanes. There are some by 4s. I don't know how many times I've had people setting up the demos that should know better from our group, from vendors that, I get calls from third parties, like software guys that do hypervisors. Hey, how come these cards don't hit line rate? I've got this server and I've got these cards in here, and I can't get over 24 gigs. That's the magic number there. If you look at the bidirectional, that's where you'll see that maximum kick in. If you're trying to get line rate, you'll on both ports, bidirectional, you'll hit about 24 gigs, and then you top out. If it's a by 4 electrically connected slot. We're working with all the OEMs to make sure that they mark the slots, they screen print it, they put the little diagrams on the lids. But a lot of cases, you get these servers already with everything plugged in. So you got to make sure whoever's configuring your servers up, get these into the right slots. Now there is one other aspect of this, is that when the PCI Express trains, when it's booting up and it does its training and creates the link speed, it may not link with all 8 lanes or at 5 gigs. It may only link at the 2.5 or a subset of the lanes. So if you go in and you grep the VM kernel log, and I just use Express. That seemed to be the easiest way to get this information, and it will tell you what each one of the ports are linked up at. So that will help you ensure that you have adequate connectivity and that you're going to have adequate bandwidth for those ports. So as you move from a bunch of 1 gig ports or 2 10 gig ports into multiple, make sure that that they are linking up and have the appropriate bandwidth. Now you can run a a dual port card on a by 4. It's legitimate. You just need to know that you have that bandwidth limitation. So you can set up an active standby, one port active and the other port standby on that one link, and so you can allocate the bandwidth across the system appropriately and still maintain full line rate on the active links, and those passive or the standby links are there in case there's an issue, and then you can, typically if that's the case, you're going to migrate off that box because there's a failed component on it. So there are ways of using by 4. You just need to be aware of which ones are, which ones aren't, so you're not loading it up and expecting bandwidth that's not available. So I said that we can hit line rate across multiple 10 gig ports now. That wasn't the case when 10 gig was first out, especially before the 5500 series processors and the Halem. We really had to implement this multi-queuing technology where we take the bandwidth and separate it or spread it out across multiple ports. We are still taking advantage of those types of technologies with 5.0. And the key is that these are all being done dynamically under the covers. And I know from an Intel perspective, we've talked about VMDQ and NetQ. It's been there for quite a while. Everybody's, yeah, okay, we know what that is. So I just wanted to point out a couple pieces. All the traffic ends up staying on these default queues until you hit a certain bandwidth or line rate. And then once you've hit that line rate, once that VM has, or the VM kernel, then it goes into either a receive or transmit queue, depending on which one has broke that limit, and then it gets its own dedicated resources. So these transmit queues get assigned by the hypervisor and by ESX, and then the VM gets brought down into it. As soon as it stops having that level of performance, line rate, then it will get moved back into the default queue. This helps us maintain lower CPU utilization because of interrupts, and then also when we do have a high bandwidth, we queue up the traffic onto these queues. We align it with the core that the VM's running on, and then we transmit it up, and everything's all prepackaged for the hypervisor, so it goes a lot faster. The other thing is you can look at the FCoE traffic. It gets brought up here, in this case, on Q4, and you can watch that bandwidth allocation, or not bandwidth, but the line rate on transmit and receive for the FCoE as it's going through those queues as well. As far as making sure that you actually hit line rate, we use, I use ESX top or remote ESX top out of the VMA. Pull it up, use the N selection, to pull up the network traffic, and then I watch the megabytes on the transmit and receive. Run different scenarios. I run iPerf or iometer to drive traffic, and drive iSCSI traffic, network traffic, to the different VM kernels. You can see all that traffic coming up here, and then you can see which uplinks are being utilized, which VMs are on which uplinks, and you can watch how load balancing is happening across the different uplinks. It really is eye-opening watching how much traffic is actually being driven by VMs versus the back-end processes. Back-end processes will drive 8-10 gigs of throughput, and then you can make some decisions on that. So these are some of the tools that to make sure that your system is set up for 10 gig Ethernet. And once you get to that point, then it becomes, okay, how do we handle the bandwidth and do the bandwidth allocation through that? In the new features that I'm going to cover are highlighted there in the blue circle. I'm not going to get into the other ones. Vinky has a session tomorrow on the distributed switch tomorrow at 11:30 that he'll go into more details on some of these other features. One thing I wanted to make a comment about is these slides are really have some small font, and I know the people in the back are probably like, what does that say? The reason is I'm going to talk to the important parts. You guys can download these things and use them as reference outside, and so I really wanted to make sure that the information is there for you outside of me up here talking. I'll cover the highlights, and then when you get back to the shop, you can take a look at the details on it after the fact. So as far as teaming, the load-based teaming is one of the new features that came out in 4.1 with the distributed switch. That allows us to balance the bandwidth, as I mentioned. It requires that the bandwidth hits 75% utilization on one of the links for more than 30 seconds, and then it moves some of either the VM traffic or the VM kernel traffic onto another port. Now you can do that across multiple ports. You can select the teaming options based on what your network requirements or your performance requirements are. This one works well because it levels out and balances out the bandwidth across 10 gig. Now, for iSCSI, now you don't have to go into the command line to set up multipathing. You can do it through the multipath in the software initiator. I'll go into a little bit more detail in the next section, but the key is that you need to set up just one active link in a port group in order for that to work. So you don't have teaming here for iSCSI anymore. It's done in a different area, and I'll go into more detail on that. And then these are the different configurations here. So when you set up your teaming per port group, that gives you some granular control for those different port groups for which uplinks they're going to use. So in this case, I only have 2, but if I was using 8 uplinks, I could actually have different uplink assignments per port group, so I can have one switch and dynamically allocate my uplinks. And thanks to the graphics people here, they screwed up my box there, but what I'll talk about here is the network I/O control. So this allows us to do traffic shaping, or not traffic shaping, but traffic control by traffic type. And this is critical when you're talking about 10 gig, because now everything's over a single pipe. In the past, we used to just say, okay, this is our iSCSI 1 gig, this is our management, this is what this, and it goes through each one of these different types. Now we do that through traffic types across one pipe. You can set it up with your port groups, and one of the new features is this user-defined resource network pool. And you can use that for SLAs or other models, but the piece that's kind of screwed up there shows that you have a gold level, a silver level, and a bronze level. Gold level doesn't have any bandwidth limitation. It has high shares. Bronze is limited at 1 gig and it has low share allocation. And the example that I have on this next foil is I've set up the resource pool, assigned this VM to the bronze pool, but I didn't put a limit on it. Now, this customer may, or group is only allocated 1 gig of bandwidth, so I can go in and adjust this dynamically or on the fly, put in a 1 gig host limit, and any VM or any services assigned to that resource pool will then be dropped down to 1 gig of bandwidth. And so I can easily move people from one SLA level to another SLA level using that type of tool. One of the other things is that's part of network I/O control and a new feature is the 802.1p tagging, or priority tagging. It's been around, not a lot of switches and not a lot of people implement it, but wanted to make, call out a couple different aspects. Network I/O control handles the inside of the box. And when it transmits the packets out of over the uplink, it does the tag at that point. It doesn't do anything with the priority tagging inside of the box. So it's just the external. Now, that's important because you got to work with the networking switch, person who's configuring the switch and the infrastructure to make sure that that's supported on the outside for that to be taken advantage of. There are also some pieces on the release notes that I'll call out every once in a while here. All traffic that is not set with an explicit traffic priority when network I/O control is enabled is sent out as 0. Okay? Even if your VM has the class of service set, whatever port group you have assigned to that VM and whatever priority class is set to that port group through the network I/O control to this is what it gets sent out. It ignores and overwrites what's done in the VM. So you need, if your server administrator has set up different priority classes, you need to work with them to make sure that you're transmitting what they need out of that, and then work with the network switch guys to make sure that that is being utilized on their side. One of the other things is that some Cisco switches will drop tagged packets if it's on the native VLAN. So you need to make sure that the VLAN assignments are appropriate also, and you're not transmitting these over the native VLAN. One way to check and see if there's an issue, disable network I/O control. If the packets show back up, you may have an issue in that area. One of the other benefits that 5.0 has is that now we can span vMotion across multiple ports. So in 4.1, we went from two concurrent vMotions to either 4 or 8, depending on if you're running 1 gig or 10 gig. And in 5, they've done enhancements to vMotion in general, but the other thing that they've done is been able to span it across multiple 10 gig ports. So this will significantly decrease the amount of time it takes to do especially a large VM. So we can do 8 concurrent VMs across 4 10 gig ports when you're using a distributed switch. So the caveat on this one is that there are 16 available for 1 gig. If you have 17 or more adapters in your VM kernel, vMotion will fail. Just bring it back down to 16 and it will work back. So it was in the release notes. I thought it's kind of obvious. You support 16, don't put 17 on there. But it's in there. I wanted to call it out. And the other thing is that you only want one vMotion VM kernel set up. So make sure that all the ports that you want for vMotion are in that one port group, and then you have additional controls there also. Direct path. Just wanted to call this out. The direct assignment of a single 10 gig port to a VM, there may be a reason to do it, but you do burn the entire port. You really need to weigh out the cost of that and the performance benefit, or the performance benefits that you get. But also there is a list of features that aren't available when you do a direct path assignment. And then there's some of the other release notes down there on other things that don't work when you do direct path. Okay, so moving into the storage side of things. And the box is supposed to be around the FCoE piece. So much for all the reviews we do on these things. So the software adapter for FCoE and iSCSI are available native in 5.0. The FCoE works on any of the X520 adapters. The X520 is the Intel adapter. The controller is the 82599. So some of our OEMs will have 82599, or they'll name their controller something else. If you see the 82599 or the IXGBE driver, that's the port that supports this. Just wanted to do a quick overview of what it takes to do Fibre Channel over Ethernet. In order to do it, we needed to create a lossless Ethernet network. DCB was a program that we worked with the industry on, and there's a series of standards which allows us to have the lossless Ethernet for the Fibre Channel transmits. So it's made up of these 5 different standards, and we're only going to talk about the top 3 here. The other 2 are more on the networking side, and they're not as relevant to this discussion. DCBX, that's how we set up our controllers. So our controllers are set up in willing mode, so we get the switch configuration, or the configuration of DCB from the switch. It programs us, and then that's how we handle the traffic classes and the flows. And that's how these other 2 aspects get set up as far as the priority flow control. So the priority-based flow control allows us to pause one traffic flow instead of having to pause the whole link. So typically in like 802.1p, you have to pause everything in order to slow it down and then start it back, and then it starts back up. In this case, we can just pause one traffic flow and the rest of it isn't affected. Then we have the ability to allocate certain amount of bandwidth of the pipe to the different traffic classes. In 5.0, the FCoE, the 2 traffic classes that are utilized are FCoE and the LAN traffic. So the FCoE initiator, native initiator that's built into 5.0 handles the FCoE protocol. That's where that's being, all the processing's being done on that. Our driver it works with the DCB and handles all the QoS in conjunction with the VMware driver. We do have offloads in our controller, and that's kind of the misnomer about software initiators, is that it's all being driven in software. There aren't any offloads compared to a fully offloaded where the protocol is actually being done on a network controller processor, not being done in software at the OS level. We do have the offloads. There's a bunch of them in the speaker notes that will be available if you download this presentation. It goes into each one of them and the benefits. We do have the priority classifications, and that's where the traffic classes, the flow control, all gets done in the controller. So that isn't being done in the operating system, by the host processor. That's being done by us and the external switch. The other aspect is we work very closely with the chipset and processor team. We know what the roadmap is for where the systems are going, what kind of power. We also know where the bottlenecks are, and we work with them to remove those at the platform level. You saw that when we moved to the 5500, the Nehalem processors. You'll see that in the next generation coming out, where there's some advancements that significantly increase I/O performance. So by having the protocol stack being done by the native initiator, having the offloads and the data path being done in the controller, and then being able to take advantage of offloads that are on the processor and chipset side and the performance gains, we take all 3 of those vectors and we can provide a high performance and highly reliable environment. This, you'll see some numbers coming out. We can drive full 10 gigs throughput of FCoE traffic on both 10 gig ports in the report that you'll see coming out. So to configure this, the big thing, make sure you configure the port that you're on the switch that you are plugging this port into. That's, I won't tell you who did it, but there was a demo and some benchmarking that was being done by a group that just came out with this, and that was the issue. They couldn't get the initiator to work because the port on the switch wasn't configured. That's where we get our information. That's how we know to enable FCoE on that port. Make sure you configured the switch and DCB for FCoE traffic. That's the first thing. Second, then you have to go in, and it's kind of counterintuitive, but we do need to be able to communicate on the LAN traffic over the LAN to get information through LLDP. So you have to set up those ports into a port group and put a VM kernel on it. And so we can communicate to the switch to use FIP and get the DCB configuration. So that's one thing. Once you get both of those configured, then it's really straightforward. You go into your storage adapter and click software adapter, and it will tell you the 4 ports or up to 4 ports that you have options of putting the software adapter on. So then you can pick the physical port that you want to put it on, and once you do that, then it's just standard FCoE configuration from that point. It's very simple as long as you get those first 2 steps right, and I wanted to make sure that those got called out. You can go into the ESX CLI, go to the FCoE, and look at the NIC and adapter list to make sure that everything is correctly configured or configured how you expect. We, as I said, we're in willing mode on our adapter, so those settings there are not settable, and so you'll see those come through. The VMNIC 4 is active for FCoE. VMNIC 5 is not. And then you can look at the adapter list and you can see VMHBA 38 is an FCoE adapter. It's on physical port VMNIC 4. And you can see the information that was provided to make sure that what is being provided by the switch is, in fact, what is expected. One of the other things, you can do multipathing. That's all done up here in the multipath tab. Pull that up. It is set up by default for fixed port selection. So if you are using like a Lua on your and your storage device is expecting load balancing, then you need to go and modify that on an ESX to correspond, or else you end up staying on a single port. There is an entry in the release notes about the storage map. If you bring the storage adapter in while the host is in vSphere, sometimes you'll get an error on the storage map. It's some odd looking, says something about it can't handle the serial, what was it here? Failed to serialize response. So if you see that pop up, the workaround is that you don't put the software adapter in first. We're going to continue to work with VMware to get rid of that. But so if you see that error come up, that's where that is. I think it's. Put this in here. We can either do consolidated configurations with FCoE with storage, where you have your unified network, or you can actually still use the dedicated links. You have full control of however you want to do that. If you want to run all your iSCSI and FCoE over one port and all your LAN traffic over the other, that's all based on configuring the the uplinks for that, or if you want to run your iSCSI off of the other ports and just run FCoE, you can do that. So whatever way your architecture or network layout needs, we have full support for that. In order to see all of the traffic that's going on those NICs, on those uplinks, you need to look at both the network and the data adapter screens in ESX top. And then you can see how much bandwidth is across that is actually going over the network. Now that becomes important because DCB can level out your, and allocate based on how the switch is configured. So the network administrator will set up the switch for DCB. By default, most of the switches are like 50-50. So 50% FCoE, 50% LAN. Somebody may configure it 80-20. That means 80% FCoE or LAN, but most likely FCoE, and 20% the other way. So 8 gigs, 2 gigs. The only time you'll see this is when there's contention. Any of these network control things, they usually only kick in when there's contention on the wire. So if your normal FCoE traffic is around the 1-2 gig mark, you're really not going to see much of DCB is not going to kick in, and you're not going to see much contention. And your network traffic can spike up to 8 gigs and whatnot. But if you're driving a ton of FCoE traffic, or anything over 5 gigs, then you'll see contention as soon as your network tries to get more than 5 gigs of traffic, and it may not make sense if you don't know this is there. Right? If you don't know which ports use DCB versus which ones are running iSCSI versus FCoE, which paths are being utilized for iSCSI, FCoE, and then which ports are being used for your LAN traffic, you may see, somebody kicks off a backup or is moving something over the FCoE, and then LAN traffic starts to get impacted and reduced based on that DCB setting. There isn't a really good way of knowing what DCB was set up, what that priority class allocation was set up from VMware right now, inside, so you have to work with your switch, whoever's configuring your switch, to get that information. So with that, network I/O control is unaware of the FCoE traffic currently. So even though it will think that it has 10 gigs, because it does, in reality it has access to 10 gigs as long as there's no FCoE traffic. It still reports 10 gigs. It's going to do share allocation based on whatever bandwidth's available, so it will, percentage-wise, it will be the same. The amount of bandwidth will fluctuate depending on how much FCoE traffic is going. Load-based teaming, we're still working around that and seeing how much bandwidth or how much knowledge it is aware of the FCoE traffic. I've seen it actually move with 5 gigs of traffic on FCoE, which theoretically it wouldn't be able to do because it wouldn't ever, network traffic on that for that would never get over the 7.5 gigs or 75% utilization. So I've seen it move, and we're still researching and working with VMware to figure out what the impact is. I think that one works pretty well. The other one works well too. It's just you have to be aware of what's going on. So if you start getting these anomalies, take a look at that. What time? Okay. iSCSI, I brought this up before. We support the iSCSI initiator. In order to do teaming, you do it in the multipathing here. You don't do it in the teaming or failover section anymore. In order to configure it, you set up a port group, assign that port group to one and only one active uplink. And that's the key here. Make sure that it's the only active one, and In order to set up redundancy, you set up another port group with the other adapter, and you do that for as many uplinks, up to 8 uplinks can be used. Then you set up your VM kernel for that uplink on that port group. You do it for the other one, and then you go into multipathing, and then you can assign it there. It's all GUI, but that's something that you have to watch for. Now, I have had, when I've added uplinks into my server, so when I've added a network card into the server, they automatically get put in as active. This hates that, because now what used to be compliant has multiple uplink, multiple active uplinks, and so then your iSCSI comes back and says that it's not compliant anymore. So if you see non-compliant, go back in, especially if you've increased the number of uplinks or added a network card to make sure that it's still a one-to-one relationship. Put this in. We support the IBFT or iSCSI boot on our adapters. We have since 4.1. The key here is that by default, we ship out our adapters with PXE boot ROMs. So if you do want to use this feature, go out to the Intel site, download the IBFT EEPROM firmware image, update the image, and then you'll have access to this. So we get a lot of support calls on, well, you only support PXE. Now you just have to change the EEPROM image on the adapters, and then iSCSI boot is supported. Not going to go into a lot of details on this. VMware does an excellent job documenting it. Just that's the piece that we get a majority of the calls on. So I do these best practice white papers. Another group at Intel will take aspects of those and work with our partners to create reference architectures. So the Cloud Builder program has step-by-step directions in these reference architectures on how to configure a wide variety of different architectures, especially around the cloud. We have a super session on Wednesday morning at 8:30, so if you want more information and more details on specifics, that's a good session to go to. The remainder, I have a couple different architecture or layouts here that I'll go through, and then I'll open it up for questions. I think we still have a couple minutes here. In this case, actually, we were at dinner last night with a couple of VMware people, and we were talking about multiple 10 gig uplinks, and I actually do get people coming to me and say, hey, I've got 8 uplinks running, 8 10 gig connections running, or I'd like to, and this is the architecture. But a lot of people are still trying to move those 8 to 12 gigabit ports down to 2 10 gig ports in order to simplify. You can do it. The tools are all there. The summary that I have in my 4.1 white paper, QoS, is really implement QoS when you need it. That's why I spend the first part of this making sure that you can look and see where the traffic is, know where the bottlenecks are, because sometimes people are trying to put QoS policies in because the adapters actually aren't hitting line rate, and they think there's some other issue. So that's why I spent the first part of that going over making sure that you have the capability. The benefit with like network I/O control is that it's pretty simple. It's pretty straightforward to do, and it gives you some easy levels. There are other ways of doing it, obviously, and other methods, but this one's pretty straightforward. The dual port, we can do all the traffic. In fact, the demo that we have in the booth is a dual port example. All traffic, FCoE, iSCSI, vMotion, everything running over 2 ports using a very similar scenario here. And that's what I did when VMware announced 5.0 on July 12th, we were actually at Cisco Live, and that's what our demo was. And we were vMotioning between the Panduit booth and our booth, and the vMotions were just screaming fast. And it was before before I was aware of the multi-port vMotion teaming and the enhancements. I was blown away. It was like 14 seconds to move 8 VMs. I'm like, normally it was like 45 to 90 seconds, and I'm like, I had to go back, make sure they were running, and I don't know what's going on here. And that's when I found out that they had put this thing in there. They kind of snuck it in on me. So this is a configuration. As I mentioned, we do get quite a bit on the storage side saying, nope, I want to keep my storage separate. Very easy to do with 410 gig ports. The key is making sure that you understand what needs to be on those other ports and how to manage those. This one, so the 610 gig and 1 gig, I wanted to kind of lay it out and try to figure out why you would do this. There are some ways that you could have separate have separate FCoE and iSCSI traffic going to a dedicated network. You could have iSCSI on your normal LAN so you could have a separate storage subsystem for that. Obviously you have NFS and different aspects there. But really when you get into the multi-tenant stuff, it will allow you to spread your bandwidth allocations across multiple ports, allocate those different resource pools to different uplinks. So in the case here, I have the gold level SLA on ports 1, 3, 5, and 6. So there's 4 10 gig ports available to it. And then with the bronze, there are only 2 ports. So 1 and 5, I think is what I put up there. And then silver has 3 ports. So you can allocate bandwidth that way. So your SLAs, you can make sure that they have bandwidth you can utilize 10 gigs. The thing that I don't like is letting 10 gig pipes sit there because the traffic that is dedicated to that isn't around. They're being underutilized. If the network can support it and the adapters are there, then do the load balancing, balance it across, make sure that you're taking full advantage of the 10 gig infrastructure. I mean, the ports, are coming down in price, but they're still, they give you an opportunity to simplify your networks. And I mean, when you look at this, 8 10 gig ports or 6 10 gig and the 1 gig may not look like it's simplified, but try to do this across physical, a physical environment, or having to use multiple different hosts. This gives you flexibility and a lot of dynamic allocation of resources. One of the other things, 1 gig is still where your power management in Wacom LAN is still going to be. As I mentioned with 10G-based-T, I'm working with the OEMs that are building them in as LOM to make sure that they do have Wacom LAN and IPMI capabilities. The adapters still are going to be challenged because the PCI spec for standby power is like less than a watt or something like that, 300 millivolts or something, and unless you can get down to 100 megs and your PHY can drop down enough of your filters to get down to that power requirement, it's challenging. So we're working with them to either add in auxiliary power, but then that adds overhead on on a server that's running in standby. So we are working on that. We are working with some new management standards that would allow you to come in and talk to the BMCs over a standard add-in adapter through MCTP. So that may, if you have 10 gig connections and you do need that power up capability, there will be some new options coming out in the next generations. So with that, under additional resources here, my contact information, the heavy at, I'm on the VMware site on Twitter, the Intel Ethernet, that's our group site, and then the Intel communities under Wired. If you have questions, if you have challenges, if you want to see a feature, anything, please put that up there. We are trying to get as much influence into our products as possible. And then just want to, Scott Lowe help review the content. He has a great book that's coming out. I haven't seen it. I have the original one, the 4.0. That was a great book. I have high expectations for that. And then I did use some of the stuff that Duncan and Frank have in their clustering book. So wanted to make sure I gave credit, and all the other bloggers that put stuff out. I see some bandanas every once in a while. There's some stuff, if in the bag you wear it, the prize patrol give you a little prize. Come out to the Intel booth, 738. As I mentioned, we have the Cloud Builder super session tomorrow, or excuse me, on Wednesday morning. Have to put this one in, VMware made me, and I do appreciate the feedback, so fill out the surveys. And come see us at the Intel booth. Thank you.